Good day to Doctor and my fellow friends. I am Victor Yongwei-Tek, metric number AF200134. My group member consists of Tan Guozi, Hui Wenhao, Ho Jizhong, Tan Mingkai, and me. We are from Group 7, Section 1 for the subject Mechanical and Electrical System.
Hello everyone, my name is Hui Wenhao and I will going to begin the introduction. So in our project, the two-story terrace house is selected as our case study in the M&E design because the proportion of the house is almost 40% in the Mauritius. The purpose of the ISIS of the design of the M&E is to satisfactory the thermal comfort and the indoor air quality of a house. So, to achieve the purpose, we will install the mechanical ventilation system. The system can adjust the air indoors and outdoors to achieve thermal comfort and IAQs. Next system is the air conditioning system to further increase the thermal comfort due to the hot weather in Malaysia. The electric and distribution system to provide the most efficient and effective design of the M&E plants.
Good day to you, Doctor. My name is Tan Guozi and my matrix number is AF200164. The topic I'm going to discuss is mechanical ventilation. Ventilation is a process by which move outdoor air into a room or a building and distribute the fresh air within it and remove the settled air to outside. The general purpose of ventilation is to control indoor air temperature, humidity, air motion so that it will benefit thermal comfort. Besides, it also helps to control the indoor air quality by diluting and remove the originating pollutants in the building. This process can be accomplished by either mechanical ventilation, natural ventilation, or mixed mode ventilation, or as known as the hybrid ventilation. Mechanical ventilation is driven by mechanical fan. This fan can either install directly in walls, windows, or even in air duct to supply air into or exhausting air from a room or building. Mechanical ventilation is divided into 4 systems, which including exhaust, supply, balance, and plenum system. Exhaust system can be done with the help of mechanical ventilation fan by creating negative pressure in the building envelope. Due to the pressure difference between the indoor and outdoor, the air is sucked in through the ventilation openings, as shown in the figure. As opposite to the previous system, the ventilation fan can also create positive pressure by supplying fresh air from outdoor into a building envelope, and due to the pressure difference in indoor and outdoor, the indoor air are forced out from the building envelope through small opening to prevent outside moisture and pollutant from getting in through this passage. Besides that, the balance system are normally use 2 fans to supply and exhaust air, and normally these 2 fans are working simultaneously to create balance or neutral pressure. Although the balance system is more complex than other systems, but it can provide better fresh air distribution toward the whole building, as shown in the figure. Lastly, plenum is a separate space that can facilitate air circulation for heating, air conditioning, and ventilation, and it is usually provided in a space between structural ceiling and a drop-down ceiling or under a raised floor. The air pressure inside the plenum is usually higher than outside, and it is usually for heating, ventilating, air conditioning equipment, cables, piping, air luminaries, and much more. In this section, I'm going to discuss about the calculation of the ventilation parts. The diagram above shows the area of bathroom, living room, and kitchen. From the equation Q equal to NV over 3600, there are 2 things that we are required, which is the area and the number of ACH. For this case, the area of the bathroom is 10.52 meter cube and the ACH required for bathroom is 10. So after substituting the value into the equation, we can get the Q required as equal to 0.03 meter cube per second. Besides that, this is the calculation for bathroom 2 and the total volume is 18.2 meter cube. And after the calculation, we can get the Q required for this bathroom is 0.05 meter cube per second. And the next one is the bathroom 3. The total volume of our bathroom 3 is 8.51 meter cube and the Q required is 0.02 meter cube per second. Besides that, the total volume of the living room is also shown as this slide, which is 108.2 meter cube. The Q required after the calculation and we can get is 0.24 meter cube per second. And lastly is the calculation for kitchen. The total volume of kitchen is 47.1 meter cube and the Q required is 0.26 meter cube per second.
Good day, my name is Hu Zhijong, matrix number AF200144. Today I'll be presenting discussion. As for mechanical ventilation in bathroom, two propellers are proposed. They are KDK20AQM8 and KDK15AAQ1. As a result, KDK20AQM8 is chosen mainly because of its high cost-performance ratio compared to the other one. It has higher capacity and lower price. As for mechanical ventilation in kitchen, Kind exhaust fan EF1201 and Cool Power kitchen exhaust ventilation fan are proposed. As a result, Kind exhaust fan EF1201 is chosen for its lower noise level and lower power consumption. It also has lower price compared to the other. As for mechanical ventilation in living room, SDCEF12 ceiling type exhaust fan and Limax exhaust fan ceiling tubular are proposed. As a result, SDCEF12 ceiling type exhaust fan is chosen mainly because of its high cost performance ratio. Despite higher power consumption, it also has higher capacity and cheaper price. Besides, the noise level is also lower.
Hi everyone, I'm Tan Min Kai, metric number AF200130, and I'll continue to present the air conditioning system. Wills Savilian Carey created the first contemporary air conditioning at Brooklyn, New York in 1902. It can reach the thermal comfort of human being, which is 25 degrees Celsius easily, and allow us to live in a comfort, cozy, containment, and livable place. In addition, air conditioner can absorb the heat drop by decrease the air erasure and increasing the indoor quality by removing the dust, pollen, and allergens. This will create a healthier atmosphere for human beings. The refrigeration cycle is practiced in air conditioner to achieve cooling. The refrigerant vapor will be moving to the condenser after it is compressed. The compression creates superheated vapor, and this will be causing the vapor to change into high temperature and high pressure liquid in the condenser. Its stage will change again when it passes over the metering device. The refrigerant will be boiling and becoming fresh gas. The remaining liquid refrigerant transforms back into a vapor, whereas the mixture of the liquid and gas pass through the evaporator. The refrigerant will then flow to the suction line and then to the compressor. The refrigerant cycle will be repeated again and again. Next, we proceed to calculation of air conditioning. The room size of the living room is 346.62 feet square. The BTU value is 8,000. Due to the condition is heavily shaded, we reduce the capacity by 10%. The number of person is 8. BTU value is 4,800. The total BTU is 12,000 BTU, which is equal to 1.5 horsepower. Hence, we have to install 1.5 horsepower aircon in the living room. The room size of master bedroom is 346.62 feet square. The BTU value is 8,000. Due to the condition is very sunny, we add the capacity by 10%. The number of person is 2 and the BTU value is 1,200. The total BTU value is 10,000, which is equal to 1 horsepower. Hence, we have to install 1 horsepower aircon in the master bedroom. The room size of bedroom 3 is 150.62 feet square. The BTU value is 6,000. Due to the condition is very sunny, we add the capacity by 10%. The number of person is 3. The BTU value is 1,800. The total BTU is 8,400 BTU, which is equal to 1 horsepower. Hence, we have to install 1 horsepower aircon in bedroom 3.
Air conditioning system in living room. Samsung 1.5 HP Win-Free Premium Aircon with inverter and Panasonic 1.5 HP Standard Non-Inverter R32 Aircon are proposed. As a result, Samsung AR13 BYEA is chosen. It's more energy saving and can be controlled remotely. It also has lower noise level. 5-star rating is also given for its energy efficiency class for cooling. Air conditioning system in master bedroom and bedroom 3. Panasonic 1.0 Standard Inverter R32 Aircon and Hisense R32 Standard Air Conditioner are proposed. After taking all the criteria into consideration, Panasonic CSPU 9X-KH1 is chosen as it is less energy consuming and has lower noise level. It is rated as 4-star for energy efficiency class for cooling.
In the last part of our presentations, I will discuss the electrical distribution system of the two-story terrace house that we selected in this project. The electricity is carried in a long span from the power generations to the residential area through the transmission line. There are two methods to carry the electricity, which are the overhead method and the underground method. The overhead method usually used in the residential area. The electricity supply from the power station to the fixtures and appliances in the house to function well. There are several essential components in the residential electrical system such as the meter, circuit breaker, wiring network, switch, sockets, and fixture. The electrical distribution system must be safe and convenient to use for consumer. Figure beside shows the symbol of the electrical distribution system of the two-story terrace house. The example of the symbol that consists on the electrical distribution system are distribution board, exhaust fan, lightning point, sockets, switch, aircon, and meter. The picture clearly shows the ground floor electrical distribution plan for the two-story terrace house. There are various symbols that can be found on this plan, such as the wiring network, switch, socket, exhaust fan, and air condition. The selections of air conditioning and exhaust fan are based on the calculations that we done. And the number of a socket that we install in each part of the houses are according to the previous research. On the other hand, this is the first floor electrical distribution plan. It seems like the ground floor electrical distribution plan. It also consists of distribution board, wiring network, lighting, fan, and air condition. In this floor, there are 3 bedrooms where they installed by air conditioning. The selection of air conditioning is based on the calculation that we done before, in order to achieve the thermal comfort in the room that accepted by the occupants.
As a conclusion, the MME system measures the performance of the buildings. There are 4 aspects to measure the performance of the building. The first is the energy consumption of the building. A proper design of an MME system able to achieve a most effective energy consumption. The air quality index able to depend on the ventilation's capacity. The thermal comforts of the buildings can achieve by provide the mechanicals and ventilations and air conditionings. The operation of the buildings. The electrical appliances play a critical function to give the service for the occupants.